Course 3, Lesson 46, we are going to be looking at solving problems using scientific notation, being able to multiply and divide with scientific notation. So, we are first going to look at multiplying. So, if we are multiplying two numbers in scientific notation, first we multiply the two numbers. These are the ones that are between 1 and 10, and then we will multiply the two powers. So, it seems kind of silly to be multiplying out of order here, but remember, multiplication, we can use the commutative property. So really, we can move this 4 to be next to the 1.2 so that I do 1.2 times 4 is 4.8. And then I can multiply 10 to the 6th times 10 to the 8th. And remember that when we are multiplying numbers that have the same base, we can add the exponents. And our last thing that we need to do is check to make sure this is in scientific notation. And in this case, yes, we have a number between 1 and 10 multiplied by a power of 10. And the second one, we multiply 7.5 and 2 to get 15 times 10 to the 7th. But you might say, well, 15 is not between 1 and 10, so isn't that not in scientific notation? And you would be right. We need to convert this. And to do that, we actually need to divide 15 by 10 to get 1.5. That would be a much better number here. Well, if I divide it by 10 somewhere in this expression, I can't just leave it like that. I need to balance that out by multiplying by another 10. So I get 10 to the 8th. Another way to remember this is if I have 15 times 10 to the 7th, right now I have the decimal place back here. If I move it back one space, that means I need to move my exponent up. Or let's say I started off with 0.15 times 10 to the 7th. Well, then I move my decimal forward, and so I have to move my exponent down. Or you can think about it as I needed one of those 10s to multiply by our 0.15 to get it to 1.5. Next, with division, it's really just the same. We need to divide the two numbers and divide the two powers. So in the first case, 4.8 divided by 4 is 1.2 times 10 to the 3rd. Remember that we subtract exponents when we're dividing, and we check to make sure it's in scientific notation, and yes, it is. And secondly, 1 divided by 4 is 0.25 times 10 to the 5th. But that's not in scientific notation. We need to borrow one of those 10s to multiply my 0.25 to get 2.5, and now we only have 4 left over. Or you can think about it as I'm moving my decimal forward, so I need to put my exponent down. Some other examples that you have right here, 1.44 divided by 1.2. Well, of course, we get 1.2. Times 10 to the 4th, and that's in scientific notation. And next we have 3 divided by 4, which is 0.75 times 10 to the 4th. We need to borrow one of those 10s to get it to 7.5 times now 10 to the 3rd. And lastly, 7.5 divided by 2.5, that's 3 times 10 to the, well, 0 power. Or you can say that's really just like 3 times 10, or 3 times 1, because anything to the 0 power is 1, so we really just have 3. Okay. So let's look at some that don't have normal exponents. So like this one, we need to say, I am going to divide 8.4 divided by 7, and I'm going to divide 10 to the negative 7th divided by 10 to the negative 5th. So I do that and say, well, 8.4 divided by 7 is, well, let's see if this is going to move for me, 1.2. And then remember, if I am subtracting my exponents when I divide, I'm going to do 10 to the negative 7th minus a negative 5. Well, if we're minusing a negative, that really becomes plus a positive, so we get 10 to the negative 2nd, which means this is actually a pretty small number. We are going to move the decimal to the left twice. Pretty small number. Okay, Another one that you can try, 4.8 divided by, and so we end up with 0.6 times 10 to the 19th. Remember, 12 minus a negative 7. And we have to move that decimal forward, so 1 less 10 to get 6 times 10 to the 18th. And you can try this one on your own. Once you've tried it, you can see that we get 8 times 10 to the negative 8th. Let's try some word problems though. Light travels at a speed of about 300,000 kilometers per second. An hour is 3,600 seconds. Write both numbers in scientific notation, then estimate the distance light travels in an hour using scientific notation. So let's start with, we have 30,000 kilometers. Well, we can say that's 3 times 10 to the 5th power kilometers per second. And we have 3,600 seconds, which is 3.6 times 10 to the 3rd. That's how many seconds we have in an hour. Well, if I want to know how far light can go in an hour, I need to multiply these two together so that I can have those 3,600 seconds of moving that fast. So I do 3 times 10 to the 5th. We're going to multiply that by 3.6 times 10 to the 3rd. And so I multiply my two numbers together. Well, 3.6 times 3, that's going to give me, well, move the decimal, 10.8 times 10 to the 8th. But that's not in scientific notation, so I need to divide by 10 and add a 10, so 1.08 times 10 to the 9th. Okay, that's how far, or our units on this, okay, we can go 1.08 times 10 to the 9th kilometers in 1 hour. Okay, and let's see here. Earth's average distance from the sun is about 150 million kilometers. Okay, big number, 150 with all of those zeros. Light travels, once again, at our 300,000 kilometers per second. Write these in scientific notation. So we get 1.5 times 10 to the 8th kilometers, and my 3 times 10 to the 5th kilometers per second. And in this case, we want to know how long it takes sun's light to reach the Earth. Well, when we do this, we're saying we have this big, long distance, and I want to know how many of these, how many of those kilometers per second, how many I can get into this one. So I'm going to do 1.5 times 10 to the 8th over 3 times 10 to the 5th, which means I'm going to get, well, 1.5 divided by 3 is 0.5 times 10 to the 3rd. I'm going to need one of those 10s to get it to 5 times 10 squared, meaning that it takes 500 seconds for sun's light to get to the Earth, which means it takes about 8 minutes, a little over 8 minutes, for the sun's rays to get to the Earth. And next one. What about if we think about Mars and how far that is? Well, that's 225 million kilometers away, which is 2.25 times 10 to the 8th kilometers. And once again, how long does light take to get there? We're going to divide by 3 times 10 to the 5th. Well, 2.25 divided by 3 gives us 0.75 times 10 to the 3rd again. That's going to be how many seconds it takes, which means I really have 7.5 times 10 squared seconds. So 750 seconds from to get the sun's rays to Mars. And last example here, one day is 86,400 seconds. Express this number in scientific notation and then estimate how far the sun's light travels in one day. So 1 day is 8.64 times 10 to the 4th seconds. And then we have my, once again, 3 times 10 to the 5th kilometers per second. So if I wanted to know if I have all of those seconds and I can go that far each one of those seconds, I'm going to multiply and get 8.64 times 10 to the 4th times 3 times 10 to the 5th. And 8.64 times 3 gives us 25.92. And our powers give us to the 9th power. But this is not in scientific notation, so we say we need to divide by 10. So we get 2.592 times 10 to the 10th. That's how many kilometers we're going to go in one day. Well, I hope this is helpful for your homework and for studying.